This is a space news update for May 25th, 2008. In the news today, NASA's Phoenix spacecraft landed in the northern polar region of Mars today to begin 3 months of examining a site chosen for its likelihood of having frozen water within reach of the lander's robotic arm. Radio signals received at 7:53 p.m. Eastern Time confirmed the Phoenix Mars lander had survived its difficult final descent and touchdown 15 minutes earlier. The signals took that long to travel from Mars to Earth, traveling at the speed of light.
Stop of Odyssey canister data and switch to 32K in 10 seconds. Odyssey switch to 32K detected. We have Odyssey locked up on the Phoenix carrier. Standing by for expected parachute deployment, and Phoenix switch to 32K. At this point in time, Phoenix would have normally deployed its parachute, standing by for telemetry acquisition. Phoenix switch to 32K detected. We have data lockup, parachute deployment trigger detected, heat shield trigger detected, ground relative velocity 90 meters per second. Ground relative velocity 80 meters per second. At this point in time, standing by for radar RF on and altitude convergence. Radar switch to altitude mode. Standing by for altitude convergence. Land leg deployment trigger detected. Ground relative velocity 60 meters per second. Standing by for altitude convergence. Radar reliable. Altitude 2,000 meters. Altitude convergence detected. Altitude 1,800 meters, 1,700 meters, 1,600 meters. Standing by for lander separation. Altitude 1,100 meters. Signal may drop out during lander separation. Altitude 1,000 meters. The separation detected. We have reacquired the signal. Gravity turn detected. Altitude 600 meters, 500 meters. 400 meters, 250 meters, 150 meters, 100 meters, 80 meters, 50 meters. Constant velocity phase detected. Altitude 40 meters, 30 meters, 27 meters, 20 meters, 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated. Helium vent detected. Standing by for normal termination of VDR comm.
During its 422 million mile flight from Earth to Mars after launching on August 4th of last year, Phoenix relied on electricity from solar panels during the spacecraft's cruise stage to Mars. The cruise stage was jettisoned 7 minutes before the lander, encased in a protective aeroshell and heat shield, entered the Martian atmosphere. Batteries provide electrical power until the lander's own pair of solar arrays spread open and begin to collect energy-generating sunlight. If all goes well, engineers will learn the status of the solar arrays between 10 and 10:30 p.m. Eastern Time from a Phoenix transmission relayed via NASA's Mars Odyssey orbiter, which is currently circling around the red planet. The team will also be watching for the Sunday night transmission to confirm that masts for the stereo camera and the weather station have swung to their vertical positions. Another critical deployment will be the first use of the 7.7 long robotic arm on Phoenix, but that will not be attempted for at least a couple days. Researchers will use the arm during future weeks and months to get samples of soil and ice into laboratory instruments on the lander deck. Later Saturday night or Sunday, we may also get the first images from Phoenix, which should give some sort of a visual indication as to its physical condition after the long journey to Mars. Phoenix uses hardware from a spacecraft built for a 2001 launch that was canceled in response to the loss of a similar Mars spacecraft during a 1999 landing attempt near Mars' South Pole. Researchers who proposed the Phoenix mission in 2002 saw the unused spacecraft as a resource for pursuing a new science opportunity. Earlier that year, Mars Odyssey discovered that plentiful water ice lies just beneath the surface throughout much of high-latitude Mars. NASA chose the Phoenix proposal over 24 other proposals to become the first endeavor in the Mars Scout program of competitively selected missions. The Phoenix mission is led by Dr. Peter Smith at the University of Arizona, with project management by NASA's Jet Propulsion Laboratory at California Institute of Technology in Pasadena, California. JPL is managed for NASA by Caltech. The spacecraft was built by Lockheed Martin Space Systems in Denver, with international contributions from the Canadian Space Agency, the University of Neuchâtel, Switzerland, the Universities of Copenhagen and Aarhus in Denmark, the Max Planck Institute in Germany, and the Finnish Meteorological Institute. This has been a Space News Update for May 25, 2008. For more news, including images, photos, and video from the Mars Phoenix lander mission, please visit the